Everything you were taught about the Moai of Easter Island is incomplete. The textbooks describe 900 stone figures carved by a lost civilization to honor their ancestors. They leave out the strangest part. The statues are not scattered randomly across the island. They are arranged with almost geometric precision along specific coastal lines, all facing inland, all of them placed on elevated stone platforms called ahu. And when a recent analysis run through the Grok artificial intelligence system cross-referenced their positions against the geomagnetic data, freshwater sources, and lines of electrical conductivity in the underlying rock, a pattern began to emerge that no archaeologist had previously named. The Moai, the AI's output suggested, may not have been monuments at all. They may have been receivers. This is not a claim anyone should accept without scrutiny. It is, however, a claim now being actively debated, and it deserves to be examined on its merits. Let's walk through it carefully. Rapa Nui, the Polynesian name for Easter Island, sits almost perfectly alone in the southeastern Pacific Ocean. The nearest inhabited landmass is over 2,000 kilometers away. The island itself is small, roughly 160 square kilometers, shaped like a triangle, carved by 3 extinct volcanoes. Its first human inhabitants, according to mainstream archaeology, arrived sometime between the years 1100 and 1200 of the Common Era. They were seafaring Polynesians, masters of navigation, who somehow crossed one of the most hostile stretches of open ocean on the planet in double-hulled canoes. Within a few hundred years, their descendants had quarried, carved, transported, and erected close to 1,000 massive stone figures, some weighing more than 80 tons, from a single volcanic crater called Rano Raraku. The standard explanation has always been religious. The Moai represented ancestors. They watched over the living. They projected mana, a kind of spiritual power, from the dead back to the community. This explanation fits the Polynesian religious worldview reasonably well, but it has never fully accounted for certain practical anomalies. Consider the logistics for a moment. Each finished Moai averaged around 4 meters in height and weighed between 12 and 14 tons. The largest, known as Paro, stood nearly 10 meters tall and weighed over 80 tons. They were not carved on site. They were carved at the quarry at Rano Raraku and then transported, sometimes for over 18 kilometers, across rough volcanic terrain to be erected at coastal platforms. Recent experimental archaeology suggests the statues may have been walked upright, rocked, from side to side with ropes by small teams of people. That theory is plausible. It does not remove the fact that the society invested an estimated 25% of its total labor output for multiple generations in this activity. The statues are too large. The transport distances are too far. The precision of their placement is too consistent. And the raw scale of the effort on an island with limited timber and a peak population estimated at around 15,000 people pushes the bounds of what ancestor worship alone can plausibly motivate. This is where recent AI-assisted analysis enters the picture. Researchers using large language models and geospatial tools have been feeding Rapa Nui data into pattern recognition systems, looking for correlations that traditional archaeology may have missed. The Grok system, developed by XAI, was one of the tools reportedly applied to this problem. The input data included the GPS coordinates of every documented Ahu platform, the orientation of each statue, known aquifer locations, soil electrical conductivity, measurements from Chilean government surveys, and historical geomagnetic field readings. The output was not a definitive answer. It was a set of correlations, and several of them were striking. The first correlation involved water. Earlier research, published in 2019 by archaeologists Robert Di Napoli and Carl Lipo, had already shown that the Ahu platforms tended to cluster near points where fresh groundwater seeped out of the coastal rock. On an island with no permanent rivers and very little surface water, these seeps were critical resources. The AI analysis confirmed this pattern but extended it. It identified that the statues facing inland were positioned at locations where the underlying basalt had unusually high electrical conductivity, caused by mineral-rich groundwater soaking through porous volcanic rock. The second correlation was orientation. Each moai faces away from the sea and toward the interior of the island. This is the opposite of what you would expect from navigational markers, which typically face outward. The AI model suggested the orientation might be better understood as inward pointing, as if the statues were aimed at something within the island itself, possibly the central volcanic cone or the aquifer network beneath it. There is a further detail that tends to slip past the casual observer. The Ahu platforms along the coast are not uniformly spaced. Clusters concentrate in specific regions, especially along the southern and eastern shores. When those clusters are mapped against the freshwater seep locations documented by modern hydrology surveys, the overlap is striking. Nearly every major Ahu sits within a short walking distance of at least one confirmed seep. In a few places, the relationship is so tight that the platforms appear to have been built directly on top of or immediately adjacent to the active water source. It is a pattern too consistent to be coincidence and too precise to be explained purely by the general availability of water, since water sources existed in many locations that were not used. The third correlation was material. The bodies of the moai are carved primarily from tuff, a compressed volcanic ash. The tuff from Rano Raraku contains significant amounts of magnetite and iron-bearing minerals. The crowns, or pukao, that sit atop the larger statues are carved from a different stone entirely, a red scoria that is also iron-rich but structurally distinct. This stacked arrangement of two different iron-bearing materials on a conductive stone base in a geomagnetically active region produces what one amateur researcher described as the rough structural equivalent of a primitive resonant antenna. The geographic setting reinforces the puzzle. Easter Island sits on a geologically young volcanic hotspot. The underlying rock is shot through with ferrous minerals, and the entire island acts as a kind of magnetic anomaly within the surrounding Pacific seafloor. Readings taken by the Chilean Navy in the 1980s, and more recently by independent geophysical surveys, have documented localized magnetic field variations across the island that are measurably different from the ocean floor nearby. Any large stone structure containing iron-bearing material placed on this kind of geological substrate will participate in the local electromagnetic environment whether its builders intended it to or not. The Grok analysis reportedly framed this observation in conditional terms. The output indicated that the physical configuration of the statues, combined with their placement, was consistent with a pattern that would, in magnetic entering terms, favor the passive collection or channeling of electromagnetic or geomagnetic energy. It did not claim the original builders intended this. It did not claim the statues actually functioned as antennas in any working sense. It simply flagged the correlation. That nuance matters. And it is worth slowing down. A resonant antenna, in the simplest possible sense, is a conductive structure of a particular size and shape placed in a particular environment. The size and shape determine which frequencies it responds to. The environment determines what signals are available to respond to. If you place a large, iron-bearing stone structure on a conductive, water-saturated base, and you do it at a location within a region with known geomagnetic fluctuations, you will get some measurable electromagnetic behavior. That is physics. It is not mysticism. It is important to be clear about what this does not mean. It does not mean the moai transmit radio signals in any modern engineering sense. It does not mean they receive messages from somewhere else. A passive resonant structure in a geomagnetic field is an object that exchanges tiny amounts of energy with its environment. You can measure that exchange with sensitive instruments. You cannot hear it with your ears or see it with your eyes. What is intriguing about the Rapa Nui case is not that any extraordinary energy is flowing. It is that the geometry and materials satisfy conditions which, in any other context, would be described as deliberately engineered for electromagnetic response. Whether the builders understood what they were building in these terms is a separate question. Whether they felt the effects in some other way, through subtle changes in the local environment, through the behavior of animals, through patterns of weather or water, is also a separate question. The question is whether the Rapa Nui builders knew this. And this is where every responsible analyst has to stop and take a breath. Not everyone is convinced. Dr. Joanne Van Tilburg, director of the Easter Island Statue Project at UCLA and one of the most experienced field archaeologists on the island, has for decades documented in detail the religious and social functions of the moai. She has argued that claims of technological sophistication beyond what the oral histories and archaeological records support tend to erase the genuine achievements of the Polynesian people who built these structures. Her critique is that the antenna hypothesis, however mathematically intriguing, rests on correlations that could easily be coincidental. Iron-rich stones near water with consistent orientation can be explained by the simple fact that quarrying convenience, transport logistics, and ceremonial tradition all point to similar choices. Correlation, she has repeatedly reminded the public, is not design. That is a strong objection. It should be taken seriously. Many of the anomalies identified by AI pattern matching tools would have shown up for almost any culture that built monumental architecture from locally available stone near critical resources. The correlation does not, on its own, prove intent. And yet a few pieces of the puzzle do not fit quite so cleanly. The first is the consistency of stacking. The pukao, those massive red scoria crowns, weighed up to 12 tons apiece. They had to be raised and balanced on top of already erected statues. Doing this without sophisticated machinery was an enormous undertaking. If the crowns were purely ornamental, one would expect some variation in whether they were added at all. Instead, certain classes of major Ahu statues almost uniformly received them. The pattern looks less like decoration and more like the completion of a required structural feature. The second is the construction of the Ahu platforms themselves. These are not simple stone piles. They are carefully fitted masonry structures, and at key sites like Ahu Vinapu, the fitting of the facing stones is so precise that observers have compared it to Inca construction techniques on the South American mainland. The platforms contain deliberate internal chambers and cavities. Some contain red scoria and obsidian chips in arrangements that archaeologists have not fully explained. The bases, in other words, are more engineered than a simple altar would require. The third is the abrupt cessation of statue carving. Sometime in the 17th or 18th century, the builders stopped. Hundreds of moai were left unfinished at Rano Raraku. Some were abandoned mid-transport along the old roads. The standard explanation involves environmental collapse, deforestation, and social upheaval. But the timing also corresponds, roughly, with a period of observed shifts in regional geomagnetic conditions. Whether that correlation means anything is unclear. It is, at minimum, another data point that models like Grok flagged for further investigation. There is also the matter of the Huri moai, the period during which many of the statues were deliberately toppled, beginning sometime in the late 18th century. Early European visitors to the island in the 1770s reported most of the moai still standing. Later visitors in the 1830s and 1840s found the majority of them on the ground, face down, with some deliberately broken at the neck. Traditional explanations describe this as a consequence of internecine warfare between rival clans. The AI analysis has suggested, more tentatively, that the toppling may also reflect a loss of faith in the function of the statues. If the moai were understood to be performing some role, that involved interaction with the environment, and if that role began to feel ineffective or malevolent under conditions of social collapse, pulling them down becomes less an act of pure conflict and more something like the decommissioning of broken infrastructure. The implications, if the antenna hypothesis holds any water at all, are genuinely interesting. They do not require lost civilizations. They do not require extraterrestrials. They require only that a sophisticated maritime people, living in close daily contact with the geomagnetic and electrical behavior of their environment, may have learned over generations that certain arrangements of certain stones at certain locations produced effects they considered beneficial, spiritually significant, or practically useful. The science we would use to describe those effects is modern. The behavior that might have produced them is not. On a technical level, this is a hypothesis that could be tested. Place sensitive magnetometers and electrostatic meters at an intact Ahu during a geomagnetic storm. Measure what happens. Compare it to a randomly chosen coastal location with no statues. Repeat the experiment under different conditions. The data would either support or fail to support the correlation. As of now, no systematic field campaign of that kind has been publicly completed. There are practical reasons for that gap. Rapa Nui is a national park, and the Moai are protected cultural heritage under Chilean law. Conducting experiments in and around the Ahu requires layered permissions from both the Chilean government and the indigenous Rapa Nui community. The community has not, historically, been enthusiastic about outside researchers arriving with new theories and new instruments. Any meaningful test of the antenna hypothesis would need to be designed in consultation with the community from the start, framed as a joint investigation rather than an external study. Some of the most careful researchers working in the area have begun those conversations. Whether they will lead anywhere depends on trust built over years. On a historical level, the idea reframes the Moai from passive monuments into active instruments, at least potentially. That recontextualizes everything about the island's collapse. The loss of the statue's function, whatever that function was, might have been as significant to the ancient islanders as the loss of their forests. A society that believed its stones were connecting it to something larger than itself, and then watched those stones fall silent or be pulled down during the internal conflicts documented in the oral histories, would have experienced a form of loss that pure material explanations do not capture. On a more fundamental level, the whole episode is a reminder of how much of our interpretation of the ancient world depends on the questions we think to ask. For most of the 20th century, the Moai were read through the lens of religion and art, because those were the frameworks archaeologists brought. AI pattern matching does not know those frameworks. It looks for statistical relationships in whatever data you give it. When it turns up correlations that do not fit the accepted story, the correct response is not to dismiss them and not to embrace them uncritically. The correct response is to go back to the field with better instruments and keep testing. There is a final, almost quiet point that is easy to miss. The Rapa Nui people themselves, in their surviving oral traditions, speak of the statues as vehicles for mana, a kind of active, flowing power. Western scholarship has traditionally translated mana as spiritual energy. But in a society paying close attention to the land, to water, to stone, and to the sky, the line between spiritual energy and the more literal energies of geomagnetism and electrostatics may not have been drawn where we draw it today. The traditions may be saying something technical in a language we've struggled to hear. What the AI analysis has arguably done is open a window onto that possibility. It is not proven that the Moai were antennas in any functional modern sense. It is shown that their geometry, materials, and placement happen to satisfy several of the conditions a person designing such a structure today would consider relevant. Whether that was intentional, incidental, or a happy accident of cultural preference shaped by 1,000 unmeasured local factors remains an open question. It is useful to place the Rapa Nui case in a slightly wider context. Across the world, certain ancient monumental sites turn out, when examined with modern instruments, to show acoustic, electromagnetic, or geological features that appear unusual. The chambers of certain Egyptian pyramids resonate at specific infrasound frequencies. Stone circles in the British Isles have been documented to sit on or near groundwater and geological fault lines. The megalithic temples of Malta show acoustic amplification in their inner sanctuaries. None of these findings prove that the ancient builders were engineers in the modern sense. They do suggest that ancient peoples, working close to the land over long periods of time, may have recognized and exploited environmental properties that our own culture learned to describe only in the last century or two. The Moai may be one case in a larger pattern, rather than isolated oddity. What is your read on this? Coincidence magnified by software, or a buried layer of ancient engineering finally starting to surface? The stones themselves are patient. They have been standing for centuries already, facing inland, watching the land they were carved to guard. Whatever they were built to do, they are still doing it. And for the first time in 400 years, the instruments exist to find out what that might be. The next few years of research on Rapa Nui may settle some of these questions. Teams with ground-penetrating radar, magnetometers, and drone-based electromagnetic survey equipment are slowly making their way to the island, often in partnership with indigenous researchers who have strong views on how their heritage should be investigated. Whatever they find will enter a debate that has been running, in one form or another, since the first European sailors stepped onto the island in 1722 and asked, in what must have been considerable bewilderment, who could possibly have built something like this in a place this remote? The question is still open. The answers are getting more interesting.